So hello, welcome to the presentation about verified boot and firmware updates and how to do them securely and openly. Um, the original author, Michał Kopeć, my colleague from FreeMDev, who's the original author, could not present it today because of health reasons. Um, a little bit about him. He's a firmware engineer fellow at FreeMDev since 2021. Uh, he mostly develops Dasharo for laptops, network appliances, and other platforms. And he uses Arch Linux. Um, Me, on the other hand, I'm Michał Żygowski. Also, I'm a firmware engineer at FrameDev. I worked there since about 2017. Also developed Dasharo. Mainly, I'm open source firmware, hardware, and security features enthusiast. Uh, and today I would like you to describe how verified boot works in general in firmware. How does it look like in Chromebooks and Dasharo? I will state what is the actual problem of the verified boot state in our firmware and open source firmware in general. A little bit about other verified boot solutions like BootGuard, CBFS verifications, and as well as secure firmware updates. So let's start with the most basic one, the verified boot. So this is basically a mechanism that performs cryptographic verification of the boot process or the boot stages to ensure only the valid and authenticated code can be executed. So only the trusted source is able to provide the code for the platform. Um, and one of the implementations of such verified boot, which is supported in Coreboot, is Vboot, which is Google's implementation of a verified boot feature. It mainly consists of root of trust, with which, in case of Vboot, is a read-only region called recovery. Um, it performs the verification of subsequent firmware stages. The utilities are for making the signatures and signing and stuff like that are public on the Vboot repo. It uses a special firmware partition A and B update mechanism. So we have like a dual read-write partition scheme, which is also like common stuff for Vboot. And yeah, it also supports the re-ownership. Currently, Dasharo firmware actually uses Vboot as the implementation of verified boot. Now a little bit about how it is realized in Chrome OS devices. It is mainly achieved by write protecting the root of trust. So Google devices simply set up the write protect pin on the SPI chip to protect the range covered by the recovery region. This write protect pin was initially driven by some kind of physical screw on the motherboard on the older devices, and then when the security design of the Chromebooks evolved, uh, the write protect pin control was given to a CR50 security chip, which is a Google's custom security microcontroller, which is present on Chrome OS devices. And the updates of the firmware are highly tied to the operating system services, which are able to handle actually the AB update scheme. So they do update one slot in one turn, then if it confirms it is bootable and valid, it then performs the update of the second one, etc., etc. So one common thing in Vboot is that the write protect portion, so the recovery portion, is like almost never unlocked and updated. So only the A and B readable slots are being flashed. Of course, if both AB slots are not valid, then the Vboot falls back to the recovery, which is like the trusted, ultimately trusted copy of the firmware that is protected by the write protect pin. In Dasharo, we use slightly different mechanisms connected with Vboot. So instead of the write protection pin, we use the chipset write protection features like protected range registers. But also, it is possible to use the standard SPI chip write protection. However, it poses some kind of limitations what we actually can do with SPI write protection, because the recovery region has to be properly sized and aligned to match the supported flash protection ranges, and of course the design has to allow to externally drive the SPI write protection. Mainly the protection of this recovery region is aiming to protect against the software attacks. And of course, we also allow to change the protection state via the Dasharo firmware setup option if sometimes it happens that we have to actually update the recovery. We handle the updates with the Dasharo suite in comparison to Google Vboot update schemes. And we are also working on implementing the UFI capsule update process. And currently, FWPD does not understand how Vboot works, so it's like only possible to update a whole image. So it is like not suited utility to perform updates with Vboot. And as we already have experienced through our many Dasharo releases, it sometimes happens that we have to actually update the boot block, which is a part of the recovery partition. So in such cases, we have to disable the protection, and it is kind of suboptimal because even if we have all those redundant AB partition scheme, we actually cannot fully depend on the reliability of the solution. Sorry, excuse me. Yes, and for secure booting and operating system, it is handled by the UFI Secure Boot in the UFI flavor releases, while compared to the Chrome OS devices, they have a special payload that utilizes the Vboot to perform the verification of the operating system kernel and other stuff. So what is the actual problem we have with Vboot? So as I said, it's like mainly the problem of updating the recovery section as well. The problem is also with resigning and reownership. On one side, we have to provide reproducible builds. On the other side, providing keys, providing images signed with public keys is like zero security gain from this feature. And secondly, like updating the firmware and not breaking it is also sometimes a challenge, especially if we like rebase core boot and some backwards incompatible change is introduced and other things. Yes, of course, like I said, the ownership problem is also present because one has to remember to self-sign the binaries if one has changed the keys to their own keys and stuff like that. But there are also other verified boot schemes and mechanisms, and let's try to go through them quickly. One of the most known is Intel BootGuard. Uh, it is also designed to perform the verification and additionally does the measurement of the initial boot code. It also ensures that only the authenticated firmware is run on the processor. And compared to Vboot, it gives kind of stronger protection mechanism because Vboot is typically run after the CPU has been released from reset. On the other hand, BootGuard verifies the firmware before the CPU is released from reset. So we are starting execution of already trusted code. There are also some kind of caveats with BootGuard because enabling infusing BootGuard means that the platform is tied to a specific firmware vendor, like forever. And actually, the design of BootGuard does not allow one to not perform the verified boot. Of course, there is like a magic profile of BootGuard that performs verification and measurement, and does not like shut down the platform if the verification fails. However, if the verification fails, there are also no measurements done. So it is kind of useless profile in terms of like providing the flexibility. So even if you would like to have BootGuard and to provide some root of trust, you are not free to not use it and have the measurements because BootGuard will simply not measure the yearly code into PCR 0. Excuse me. Other disadvantages of BootGuard is, of course, more binary blobs in the firmware. Because in order for the BootGuard to perform the security actions, you have to integrate the authenticated COM module, which is a higher privileged Intel signed binary blob, which basically is verified by the microcode. So basically, you just can obtain it in the binary blob form. There's no available source code for that. And as I mentioned, the fusing of BootGuard basically steals you some of the control of your hardware. So unless you have access to the tools and can do things yourself, you're basically on the mercy of the firmware vendor. So providing ability to sign and re-ownership the platform with BootGuard is another challenge. Another mechanism that has been quite recently added to the core boot is a CBFS verification. One can say it is kind of simplified scheme compared to Vboot. So basically what it does is it creates an anchor of metadata hash inside the boot block, which then is used to verify every other file in the core boot image. So basically it is like a simple SHA-256 hash comparison per each file. However, it also needs some kind of guarantee that the hash anchor inside the boot block is somehow protected, because if it is not, anyone can actually override the anchor and thus inject any malicious code into the core boot image. So this feature only makes sense if some kind of verification or protection on this part of code is also ensured via other security mechanisms like boot guard or flash write protection. Of course, like the same applies for Vboot's recovery region, right? Yes, but in terms of verified boot, it also does its task, so it is a viable replacement of Vboot for the share users. So let's go through comparison of firmware update methods. So we've talked about the verified boot update scheme. We have the typical read-only and A/B slot updates. There's additional anti-rollback protection with the TPM, but Vboot is like more suitable for payload and OS integration, like a full stack solution, let's say. It works very well for Chrome devices, but for other software stacks, well, it kind of requires additional integration to actually make a full use of that. So our ideas for Dasharo how to actually use the Vboot was to leave the read-only region untouched and simply update AB regions. That's what we initially thought, of course, but in reality, it occurred that we often have to update the boot block because of some backwards incompatible changes or breaking changes, because the memory layout of those early pre-RAM stages is very sensitive to discrepancies and stuff like that. As I also mentioned, we use the Dasharo 2 suite to handle the updates, and it tries to simplify the update process as much as possible and hide all this convoluted logic from the user and all those complexity, and just try to expose as simple user experience as possible. And yeah, when we use the Dasharo 2 suite, we don't basically use the AB update feature as it should be used, because we just update everything in one way. And yeah, we hope the UEFI capsule update support may help here, but we will see. As for the other firmware update mechanisms, the FlashROM plugin in FWPD is not well suited for Vboot because it's also able to update only the BIOS region, so you have to also update everything in one way. So some kind of integration for core boot specifics would be needed here. On the other hand, we have the work in progress on the UEFI capsule updates, which is like probably the most known and widely used update mechanism because of being used in UEFI firmware, which is like the most excuse me, which is the most common firmware out there in the world, at least on x86 platforms. And yeah, it is very, very flexible because it can be made aware of which regions should be updated for given version, which regions to preserve, and then it can even handle disabling columns of flash protections, or tell the firmware to skip enabling the flash protections on the flash update boot path. Yes, there is also a mechanism called top swap. Uh, like, but however, this like mostly used in the bootguard fault tolerant update process. It serves a purpose to update the most critical parts of the code securely by like flipping one address bit on the bus, so that the CPU reads kind of different block of memory after reset. But that's just a small part of the firmware, right? And that's it. Now I'm open for questions.